Part 4, modeling objects in the motion. Now in this one we have to grab the function of the height of the ball in a feet, of the time in a seconds, include the labeled key features of the graph such as a vertex, axis of symmetry, x and y intercepts. So first of all, just to let me talk a little bit about this example. Here we already created this graph with Desmos. We plug in the equation and the Desmos gave us all the rest of the graph of the points and everything else. So now here, if we are looking for the domain in a real world situation, always we are taking just a, I wouldn't say always, but usually we would take the first quadrant. The domain is from 0 to here 1.629, the domain. And the range is from 0 to 13.266. So the height, we taking this height as the range. And y-intercept. Y-intercept is just let me say here, in the y-axis is h, is the height of the object, and in the x-axis is the time. So the y-intercept is 0 and 5 feet. Here is the intercept. The maximum point that reaches is 0.72 seconds approximately, if I am rounding this into the two decimal numbers, and the height is 13.27 feet. And if we are looking here for the x-intercept is 1.629 seconds. Here is the intercept. Axis of symmetry, I didn't do the axis of symmetry, but axis of symmetry is the line that intersects the 0.719 seconds in the middle, and it divides the graph of the function in two symmetrical sides. This is the axis of symmetry, and x is equal, or t, it's better to say t, is equal with 0.719. This is the axis of symmetry. And if we wanted, we found all this information graphically, but if you see, for example, here we are going in the part 2. In the part 2 we look the height, the maximum height 13.29 and time 0.72. So this 0.72 and 13 point and it was a 13.29, because when I rounded to the number, it gave me a little bit greater number, because when I rounded the number 0.719 in 0.72, when I plugged in the to find the height, it gave us a little bit greater number, but is slightly different, but is there, approximately is the same. If we are looking at the time here, the maximum time, the time when the ball landed on the ground, which is the t-intercept, is 1.629. So we already have the same. So all the information we have the same, and the graph of the function illustrates the whole work what we did in all the three parts previously.